I'm back. Hello everyone. Good evening. As I promised all of you, today I'm presenting the third video in the series of the bar bending schedule. Today we are going to learn what are the important things to be considered while thinking of reinforcement, especially in case of BBS or bar bending schedule. That is a part of estimation in contrast to the structural engineering. And also we'll be looking into types of reinforcements which are being used in different types of structural members. So let's get started without wasting any further time. Today I'm trying to keep the video as short and sexy as possible. So let's get started. In the last video I have already shown you, that was the part 1 video, I have already shown you the Bastukar's table in which you got the diameter of different bars which are commonly being used, their weight per running meter and their cross-sectional area. And there was one note in the bottom of that particular table which you can see right now. For estimators, they must memorize the unit weight of reinforcement of various data. For structural designers, they must memorize the cross-sectional area of reinforcement of various dia. So, from the structural engineering point of view, we must concentrate on only fact in a particular position of a structural member, how much area of cross section of reinforcement we must provide for that particular type of function for which we are using the reinforcement. Now I am not stating directly the tensile stress term, okay, because we can use reinforcement for various aspects other than just the flexural tension. We can use it as shear reinforcement, that is diagonal tension obviously. We can also use the reinforcement for taking up the compression in double reinforced beam, and also in case of the column, there we use the reinforcement both for taking the direct axial compression and also taking up the bending moments. In short, while we are thinking as a structural engineer, we are not of much concerned that how much weight of reinforcement we are providing in a particular area or a particular part of the structural member. We are only concerned about the cross-sectional area for the particular type of the critical nature of structural phenomena, like whether we are calculating the reinforcement for taking up the flexural tension or the diagonal shear, that is the diagonal tension, or the compression. For that particular type of phenomenon only, we have to consider the sectional area. But when we are acting as an estimator, the things get changed, because here we are not at all bothered about the structural function of the reinforcement as an estimator, not as a site engineer. Obviously, when you are acting as a site engineer, we must provide the reinforcement as per the detailing in the proper places. That time we are considered about the structural designing. But whenever we are acting as an estimator, we must not think like a designer. So what I am trying to say, whenever we are acting as an estimator, we must remember the reinforcement weight only, and in general terms, even if the detailings are not provided, then what are the different position where reinforcement is to be provided apart from the main function of the reinforcement for which reinforcement is being provided by the design of the structural nature. It is sounds to be pretty critical, right? Like say in a particular portion of a slab, we designing for the mid span. Okay, so from the view of a structural engineer, we are only considered about the reinforcement at the bottom portion, and near the support we are much more considered about the reinforcement on the top portion due to the change of the nature of the bending curve. But though as a structural engineer we know some reinforcement shall continue through the bottom, but we are not at all bothered about the provision of the bars which are to be used to keep the crank portion or the top mesh, if we are providing separately the top mesh, in its proper position by providing the shear, what we know as, by forming a bar into a shape of shear. I'm just trying to show it how it looks like. Shear is a bar, typically it is bent like this. So starting from here, going to up, turning to right, getting down and bending into the opposite direction than what was the first direction of bending. This particular thing is provided to hold up the bars which are at the top portion. This shear, we don't consider it in the case of the structural designing, but whenever we are doing the BBS, we have to give some provision for it, kept as 5% for wastage and lappings, all those things. So we have to think differently. We have to think more like an executor or a site engineer than a structural designer. This is the main difference between a person who is making a BBS and between a structural designer, though both of them are highly interlinked. Now just getting on to the next topic, various types of bars which are used in different structural members. Okay, for continuous strip footing for wall, that is a RCC continuous strip footing, there are only two types of bars: main bars at bottom along the shorter direction and distribution bars at the bottom along the longer direction. Okay, then comes the isolated column footing and pedestal, if any. Okay, main bars at the bottom in both ways for the footing itself, and main bars at top in both ways. So if in taller buildings reinforcement on both the faces are provided, so it may or may not come in isolated footing, it will depend upon the design. Dowel bars in pedestal, if pedestal is provided. If pedestal is not provided, then dowel bars are of no use. Directly the bars of the columns are cast along the footing. And lateral ties of the pedestal, okay, if pedestal is provided only, then it arises. Now I have not mentioned the reinforcement of the column because column footing and column stem are both two different things. Now I am coming to column stem. For column stem there will be only two types of bars: longitudinal bars and lateral ties or helical reinforcement. Okay, you may provide lateral ties, you may provide helical reinforcement, and there may be some hook or ties may also be needed to be provided. You can just take it a part of it, because the lateral ties which are being provided, it is not like a single bent up bar, it may consist also hooks, okay, depending on the number of bars in the column stem and their arrangements. Now any beam, be it a tie beam, floor beam, even a lintel or band, because lintel or band are also structurally a beam, there will be mainly four type of bars: bottom continuous bars, top continuous bar. Now this top continuous bar may be termed as hanger bar in case of the singly reinforced beam, where the main reinforcement is provided at the bottom only, and the top portion of the beam carrying the continuous bars are used only for hanging the stirrups. Those are acting as hanger bar. But in case of the doubly reinforced beam, those will be used to take up the compression also. And apart from this, near the support zone, those continuous bars on the top side will take up the negative bending moment also. That beam may also contain crank bars, may not contain also, it will depend upon the structural design itself. Even if crank bars are not used, it may have the extra top and extra bottom concept, both of them or any one of them. Then comes the vertical or inclined stirrups for the shear reinforcement. Now, if there is a segmented or piece lintel with chaja, so what I am trying to tell is that there is a lintel, and from that lintel chaja or sunset is coming out. Okay, and both of them are cast monolithically, as we already know. So it will contain the bottom continuous bar for the lintel, top continuous bar or hanger bar for the lintel, crank bars if needed, extra top, extra bottom bars, any one of them or both of them if needed, and the vertical stirrups with common continuation for the main bars of the chaja. This is very much important. I have already posted few photographs regarding how to bind the reinforcement for the sunset coming out from the lintel itself. I hope who are following my Facebook page have already gone through that picture. So the vertical stirrups and the main reinforcement of the cantilever, that is the sunset, because sunset is acting as a cantilever, one end is fixed on this lintel and the other end is free. So it's basically a cantilever. That vertical stirrup of the lintel will come out as the main bar of the sunset, and distribution bars will be used as. Now comes the one-way slab. For one-way slab, we are using main bars, crank bars, extra top bars if needed in case of the restraint slab and continuous slab, because otherwise if the slab is simply supported and having support on its four side, only a single panel, single isolated panel, then the end moments or the negative moments will be very less, so there will be no need of providing the extra top bars over there. But in case of the restraint slab or continuous slab, it may be needed. Definitely it will be needed to have the extra top bars, because the negative moment on the continuous slab on near the support is the governing moment which will decide the maximum amount of reinforcement and also the depth of the slab. Then comes the distribution bars. It will be provided on the other direction or perpendicular to the main bars. Then comes the hanger bars just below the crank portion of the main bars. To keep that crank part in its position, we have to run hanger bars underneath the crank arm of the main bars. Then comes the torsional reinforcement, slabs of non-restraint type. If the slab is of non-restraint type, then you have to provide the mesh for the torsional reinforcement. We know there will be two mesh, one on the bottom and one in the top at the corners. Only in case where two sides, adjacent sides are discontinuous, or at least four sides are not continuous, there must be a discontinuous end or edge. Then comes the two-way slab. There will be main bars in both ways because it's a two-way slab. There will be crank bars in both ways because main bars will be alternatively cranked, extra top bars and hanger bars as we have already discussed where it is required, and torsional reinforcement obviously for slabs of non-restraint type. Then comes the dogleg staircase. In staircase we'll be giving main bars, crank bars, extra top bars, hanger bars and distribution bars. I know that it is not very clear which bars are being used in which position actually from only just reading out. In my next video I'll be putting the detailing of that particular structural member in the screen. Side by side I'll be putting the types of bars which are being used and will identify those type of bars in that particular detailing sheet of the structural member, so that you can also know where which bars are to be provided and how to identify them. Next is the pile and pile cap. In pile, longitudinal bars of piles will be used, lateral ties and helical reinforcement, whatever is applicable will be used in pile. It is just same as the column, because pile is nothing but a slender column or a very long column. Okay. Then for the pile cap, the bottom main bars of the pile cap both ways running, top main bars of the pile cap running both ways, and distribution bars or side face bars as per the detailing sheet it will be provided. So I hope you have liked this video, and if you have liked this, then please do subscribe to this channel and press the bell icon on the bottom right hand corner and turn on the all notifications, so that whenever I'm posting my next videos, and videos will be coming one after another in this series, you can get notified and see that video without wasting much time. And please do share this video with all other friends of yours in the engineering college, or your colleagues who are working with you, or maybe were working with you, and all the other person whoever are interested in the construction field to learn and to gain knowledge. Thank you. Hoping to see you in the next videos. Tata.